Here I just want you to see some examples of acids and bases. And the general rules for these are any species with a hydrogen can potentially act as an acid. It may not be a good acid, but it can potentially act as an acid under the right conditions. Here we have some inorganic acids. That means they don't contain carbon. Things like HCl, sulfuric acid, and water. All of these can donate a proton. Over here we have some organic acids, and in all of these cases I've highlighted a proton in the molecule as being the most acidic proton in the molecule. Now there are certainly other protons in these molecules. For example, in this first one, we have a CH3, but in general, we're going to be looking for the most acidic proton. And we're going to learn how to qualitatively analyze molecules for acid strength to pick the most acidic proton. But if it has a proton, it can potentially act as an acid. Even something you may not think, like just a 3-carbon chain, you would never think of that as being an acid in general chemistry. In fact, it's a terrible acid, but if you treat this with a strong enough base, one of the protons somewhere in this molecule, and there are several, the base can take off one of those protons. On the other side, any species with a lone pair can potentially act as a base. And remember that it's our job to look at an atom and figure out if it has a lone pair. So first we have some inorganic bases. These are all things without carbon. Now when you see something like a metal and a nonmetal, sodium bonded to an oxygen, I recommend just breaking that up and writing sodium plus, O minus. So sodium plus, OH minus. Well, this oxygen, as it's written, is bonded to the hydrogen, but it must have 3 lone pairs so that it has an octet. Same thing with NaNH2, sodium amide, that's called. We have sodium plus, NH2 minus, and the nitrogen has 2 lone pairs. Next we have NH3. This is a neutral base, but the nitrogen does have a lone pair. So we can have neutral bases, we can have charged bases. And then water, under some conditions it can act as an acid. Under other conditions, it has lone pairs, it can act as a base, but this is another neutral base. On the right side, we have some organic bases. These are very similar. NaOCH3, I would break this up as Na plus, OCH3 minus, and put the lone pairs on the oxygen. Here the nitrogen has a lone pair, here the oxygen has 2 lone pairs.